Hey guys, so today we're going to look at a little bit more at the graphs of our logarithmic functions. Specifically, we're going to start looking at transformations of logarithmic functions. Now, when you're going through the next few videos, you should have already had a bit of a review on what our different types of transformations are because we've already looked at exponential graphs, but we're also going to break those down again here. So the learning target we're going to work on is I can identify transformations of functions, given the graph, the equation, or the graph. So let's talk about reflections of functions. A reflection is when you flip a function. We have two types of reflections. We can reflect across the x-axis, which would be a vertical reflection, or across the y-axis, which would be a horizontal reflection. This again moves all of the points, so this changes the characteristics of the function again. And we'll take a look at which characteristics change and which ones might stay the same. And it really depends on what type of reflection we have. So let's start with our vertical reflection. So if we have a negative in front of the logarithm, so negative log base b of x, this would reflect our graph about the x-axis, so it would flip it up and down. So it would look something like this. So if I have, again, my red is log base 2 of x, same as in the last video. My blue is negative log base 2 of x. So I have a vertical reflection here, or a reflection about the x-axis. But what about the characteristics? So the domain of our blue function, well, that didn't change at all. That is still going from 0 to positive infinity, which also means that I still have that vertical asymptote at x equals 0. My range also does not change. It still goes from a negative infinity to a positive infinity. My x-intercept doesn't change. That's at 1, 0. My end behavior, however, is going to change. So now as we move to the right forever, as x goes to infinity, our f of x is going down forever to a negative infinity. And as we move to the left to 0, our f of x is going up forever to a positive infinity. So that's what changes when we have a vertical reflection. How about a horizontal reflection? Well, this would be if I had something like log base b of negative x. This is going to reflect the graph about the y-axis, or it's going to flip it left and right. It's going to reflect it horizontally. That would look something like this. Looks kind of cool. This makes me think of like an ink blot test, right? Where you splotch on the ink and you fold a piece of paper in half and see what you get. But I digress. So for this one, we have f of x equals log base 2 of x as being our red function. And again, our blue function now is log base 2 of negative x. And notice each of these points are reflected across the y-axis. So what about these characteristics? Well, our domain changes. In fact, our domain completely flips around. Our domain goes from negative infinity to 0. We still, however, have our vertical asymptote at x equals 0. Our range stays the same, going from a negative infinity to a positive infinity. And my x-intercept it flips essentially. The x value flips from a negative 1, or from a 1 to a negative 1. So our x-intercept is at negative 1, 0. Our end behavior also changes because now our right end behavior is actually going to as x approaches 0, right? Because as we're moving here to the right, we're approaching an x of 0. We can't pass that. So this is actually my right end behavior this time. And as x goes to 0, f of x is going to a negative infinity. It's going down forever. And as x goes to negative infinity, as we go to the left, on and on and on forever, f of x is going to a positive infinity. It's going up forever.